Let's look at some of the properties of logarithms. Now this page is really something we already kind of investigated, and it's the fact that logarithms are the inverse of an exponential function. The logarithm is the inverse of the exponential that has the same base as the logarithm. So in other words, log, which that stands for log base 10 of x, is the inverse of y equals 10 to the x. And we can see that in a couple of ways. We can see that the x's and y's are going to be inverted to be an inverse. Another thing you would notice is that the graph of the exponential and the graph of the logarithm are reflections about the line y equals x. So they kind of become this mirror image of each other. Now the other properties we're going to go through one by one, and you don't have to know the name number of the property, just how to work with it. So since these are inverses of each other, do you remember that if you squared a square root, it kind of undid it? Well, this property, so this says that if I have log base b of b to something, let's think about what that really means. Okay, so equals an exponent. So I'm going to call this y, or whatever, I don't know. So this base to this exponent equals what's the argument. So b to the y equals b to the x. In other words, this is x. It's almost like this part kind of cancels out, for lack of a better word. So log base 4 of 4 cubed. Well, this base and this base match, so I just get 3. It undoes the process and gives me back the exponent. Ln really means log base e of e to the x, so it's going to undo it and just give me the exponent. Now what if it was a base raised to a logarithm? Same thing. Base raised to the logarithm, and logarithm is the power. So it's end up going to kind of undo each other, and we're just going to get the 4 back. Here, e to the ln. Ln is log base e. So they're going to undo each other, and we're just going to get x back. And I'm sorry, I just realized that my finger looks horrible. I burnt my finger. Sorry. Now let's get to some other properties. This property states that if I have a logarithm and there's 2 arguments being multiplied, I can separate that out using addition. So if I have log base 2 of 4 times 16, and 4 times 16 would be really, really big, and I wouldn't know it off the top of my head, but I know that log base 2 of 4 is 2, and log base 2 of 16 is 4, then I can separate this out and say this is really log base 2 of 4 plus log base 2 of 16, which I know this is 2 and this is 4, so this is really 2 plus 4 is 6. So I can break apart a logarithm so I can know it better. So here, the natural log of 77. Well, I wouldn't know that off the top of my head, but what if somebody told me that the natural log of 7 was this and the natural log of 11 is this? Well, 77 is 7 times 11, so it can break down into a natural log of 7 plus natural log of 11, which would mean I would add those 2 values together. So 1.9459 plus 2.3979 and get 4.3438. We can also do kind of the opposite with division. So if the two things are being divided, they can separate using subtraction. So instead of figuring out what 9 divided by 27 is, I know what log base 3 of 9 is, minus log base 3 of 27. So log base 3 of 9, 3 squared is 9, so that's a 2. 3 cubed, so I end up getting -1. Same thing here. Log of 16 over 5. I can take log of 16 minus log of 5. So 1.2041 minus 0.699, and we get 0.5051. Now this one's kind of interesting. If I have something raised to a power, this property says that I can take that exponent and move it to the front. So here, that means if I did 9 squared, that's a really big number. But I could move the 2 out to the front and make this easier to work with. Because log base 3 of 9 is just a 2, so I end up with 2 times 2 is 4. On this one, ln of 8 to the -4. I could bring this -4 to the front, and we know that natural log of 8 is 2.0794. So I just do -4 times 2.0794. Now I'll be honest, a lot of these properties were a lot more important back in the older days, because we did have log tables that we had to look things up on, so we would look up natural log of 8 and that type of thing. Nowadays you could have just put in natural log of 8 to the -4 and gotten an answer as far as evaluating. But when we come to solving equations, simplifying equations, knowing these properties and how to maneuver things is going to be very helpful. Okay, the last neat property will be very helpful if you do not have a TI-84. It's a way to convert logarithms so that you can put them into any calculator. And so the rule says that I can take a log and change it into any logarithm I want. Usually we do it to base e or base 10. Base e would be a natural log. Base 10 is just the log with no number. So what we're going to do is you take the natural log of your argument divided by the natural log of the base. Log of the argument, log of the base. So here, this would be the natural log of the argument of 15 divided by the natural log of 7. Every calculator, every scientific calculator has a natural log, even the one on your phone. So I could do natural log of 15 divided by natural log of 7. And it gives me 1.3917. If I did this with log, so the common log, log of 15 divided by log of 7, I get the same answer. So this is how you can evaluate logarithms in any calculator.